So, hello and welcome to this hot afternoon and evening, where I'll try to talk about what's going to happen with JavaScript after June, after the recent TC39 meeting in Berlin. What is this TC39 thing, and why are they meeting, and what is this all about at all? First, introductions. Hi, I'm Szabolcs. I work at IBM a few blocks from here at IBM Cloud. I'm organizing JSConf Budapest and CSSConf Budapest, and sometimes I blog at that URL. My mouse pointer is in the way, sorry. And you can find me on Twitter at _nets, NEC. Also, yeah, I'm organizing these two really great conferences, but you have heard about that enough, I think. First, raise your hands if you know what does TC39 means. Okay, so there will be some new information for some people at last. The question is, how is a language is governed, how a language is designed, how its decisions are made, where to go forward. And there are some theories, like all the great guys and people of the countries and companies gather around every year in a secret nuclear bunker somewhere in Switzerland and decide the future of JavaScript. No. There are the old people, the ancient ones, and sometimes once a year everybody has to go before them and ask for some advice and move this direction, please. No. There's this crazy young king speaking lead speak and deciding whatever they want to do and giving us names like Smoosh and stuff like that. No, we can create theories and theories. The actual thing is much more boring. There is this organization called ECMA, which means European Computer Manufacturers Association. It's a Switzerland-based company, basically. They formed it in 1961 by organizations and companies like IBM and Microsoft and, I don't know, big companies, Xerox. And what they do is creating information technological standards. So they give these strange names like ECMA and the number, and like ECMA 107 is the FAT16 file system. ECMA 119 is the CD-ROM volume and file structure. ECMA 334 is the C# language, and ECMA 404 is the JSON specification. What we are here today and what really interests us from these specifications and standards is the ECMA 262, which also known as ECMAScript. This is an international standard, so it's like a standard like the FAT16 file system, like that. JavaScript is an implementation of ECMAScript, and this standard is edited by ECMA, and within ECMA, this standard is edited by a committee, the number 39. That's why they call it in shorthand TC39, Technical Committee 39. Quick history of ECMAScript. In 1997, there was the first version of ECMAScript. Then it became JavaScript with some browsers. And from that time, every year, they create a new version, like ECMAScript 2, ECMAScript 3. And then they tried to create ECMAScript 4. And this was a really tough thing, because these companies who were governing this language find a hard time to decide what is backward compatibility, what is the pace of the language should go. And they just battling each other for 10 years. This was the dark interregnum of the language. Basically, companies going forth and back and hacking each other's neck. And after 10 years, in 2009, they decided, okay, let's drop the fourth version at all and let's create ECMAScript 5 instead. So ECMAScript 5 is a subset of ECMAScript 3 and some new versions of ECMAScript 4. And some of the stuff were just totally missed out. After 3 years, came ECMAScript 5.1. Yeah, it's a big advancement. After that time, 4 years passed. Meanwhile, this time around 2011, it was the first time when the usage of Chrome surpassed Internet Explorers. And around 2014, the Babel transpiling system came out. And this was the reason because the community started to look for new versions and new things that they can use within the language. TC39 was working with the community at this time. They were listening to the things that community wanted in JavaScript. And they helped create Babel so they can try out and use these new features before even the browsers, the browser vendors implement these. And this led to 2015 when ECMAScript 6 came out, and instantly they renamed it to ECMAScript 2015. And from this year until I don't know, every year a new version came out with the same version number or year number when they released it. So now we're waiting for the release of ECMAScript 2019. But let's talk about this process, how this language and how this committee works. The people who are sitting at these meetings are called TC39 delegates. These are people who are coming from browser vendors, so the implementers like Google, Microsoft, Apple, Mozilla, Samsung. I learned that the SAP is there because they have an own implementation of JavaScript called XS. Interested companies who are not making browsers but really invested in the language or some implementation of the language like IBM, Bloomberg, Salesforce, Igalia. And open source projects who are related to JavaScript and ECMAScript very well, like Babel and Webpack. Also, there are very wise and old people who are language design academics, and they actually know how to design a language. So what they are talking about is proposals to change the language feature ideas. All these proposals are open source. They are on GitHub. You can read them, you can talk about them, you can comment on them, you can like them with upvoting and everything. And it's really interesting to see interesting to see the discussions under these proposals. I really urge you to go there and check those out because you can see what is going to happen with JavaScript and you can see what's not going to happen with JavaScript. So like there are some proposals who are still in a very low state because they couldn't decide how to move them forward. What does that mean? Sorry, first, what the proposal is about. There's a simple description like this would be a nice feature for the language for some reason. Some examples, yeah, you write your own code examples that how you imagine this feature would work in the language. There are some possibilities and adaptations. So if you have already created like a polyfill or a Babel plugin, you can link it there. Here, hey, look at this. I'm already using it in my code and it works. And then later on, and the proposal getting more mature and mature, the specification and the tests will be created as well. There are 4 stages, okay, 4 stages of the proposals. The 0 is basically not a stage, it's an idea, like saying, I think this is a problem. Then some delegate or a champion at TC39 says, okay, let's tackle this problem. I think this is a problem. Let's identify the problem. And TC39, when they raise this proposal to stage 1, they acknowledge the problem. Yes, this is a problem, and we decided to do something about it. When they move it to stage 2, then they provide a solution, like this is how this new feature in the language will work, but let's discuss this. Do you like this? Do you, browser implementers, what do you say about this? Stuff like that. When they move to stage 3, that means the full specification is ready, members and delegates of the TC39 are reviewing it, and they start to write implementation tests. And the stage 4 is reached when there are minimum 2 implementations, like in V8 and SpiderMonkey. There are implementation tests passing, and they have some experience with implementation, so other implementers can go and ask for help. And basically, when they reach stage 4, they became part of the specification. They become part of the language officially. So these are the 4 stages. Sometimes the stepping is not always linear in one direction. Sometimes there is downgrading, like when there is a conflict between another proposal or an existing specification, or there is some conflict with a commonly used code, like a library or a framework out there in the wild. Recently, this is a good example when they tried to introduce the array flat. It became array flat recently, but they tried to make it array flatten. And they found out that MooTools have this same method of array created called flatten. So they realized if they create this the same method part of the language, they will break every site that uses that version of MooTools. And they didn't know what that number is. So they're like microsites hidden in intranets and stuff like that. They don't want to break the web, basically. This is the main motto of TC39, that they try to avoid breaking the web. So when the downgrade is happening, they redesign the proposal, go to the community, ask for their insights, what they think about this and that. That's what happened when somebody made this blog post, which basically was a sarcastic thing, that let's call this feature array smoosh, and everybody was like going nuts about that, what are you thinking? Please stop smoking weed. And yeah, so stepping is not always up. Sometimes stepping is always down with the proposals. These meetings, but they happen every 2 months in places in the world. It's a 3-day meeting, around 50 attendees. They have a really, really strict agenda. So like the talks and discussions are time boxed, and when they reach an end of the time box, that's it. They check the log, check the notes, check the transcript, and they stop there, and next time they can continue it and maybe create a conclusion that, yeah, we don't want to make a decision with it, or let's come to a conclusion and write that conclusion down. They discuss proposals. There are these time frame discussions like 15, 30, 45, and 60 minutes. All the meeting notes, the transcript, everything is public. It's published on GitHub, so you can basically read the meetings after they happen. The latest meeting was in Berlin, June, from 4th to 6th. And it was hosted by Stripe, I think, yeah. So let's recap some really good and interesting proposals and their discussions and results of the latest meeting. First is the optional chaining. I'm happy to announce that they reached stage 2. So basically, the implementation is moving forward. Optional chaining is basically if you try to access a property on an object, sometimes that property is non-existent, so you have to provide an alternative value of it. And basically, we have to test this like it's a ternary thing with one line, and they're introducing this new operator, the question mark and the dot. And this might change, so this is like a stage 2 proposal, so this operator might be something completely different. So if you don't like it, go to GitHub and comment it that I don't like this operator because of reasons. And this is not an original thing. The prior write is coming from C#, Swift, and CoffeeScript. Basically, this is what happens. So before optional chaining, you could do person address. If it exists, then let's access the person address street. And this is a really long line. The code is not that readable. And if you use optional chaining and you get used to the operator because you have to learn it basically, then you could do this. And basically, if the person address is existing, then it will return the street value. Also, like a basic DOM selector, like you're looking for an input named city, if that city input is existing in the DOM, then I want the value or another default value if it's not existing in the DOM. With optional chaining, you can do it at one-liner, like my form query selector, the selector you want to do, the new optional chaining operator, and the value or the default value. So you don't have to get the DOM selector, then check the value again, extract it into separate variables. So it gives you a quite more readable code, maybe. There's also covariant. So if I have an object and maybe it has a method, then let's call that method and check if the result is true. Or you can do, if my object has this method, then call it, and if it's true, then yeah, execute this code. So you can use this not just access properties, but to call methods as well. Short-circuiting. Short-circuiting means that if you try to access this city here from the address, from the person's address, if person is non-existing or null or undefined, then both of the address and the city won't be tried to be accessed. So it stops, the code execution stops here. It won't try to go there and there. Also, it works with calling methods. So if the person object doesn't exist, or it's null or undefined, it won't try to call the method afterwards. So it's really useful. You can create absolutely, I think, more readable code. But the next feature, which is also in stage 2, reach stage 2, helps a lot with this feature, and it's called the Nullish Coalescing operator. And you basically, I'm pretty sure you tried this in your code. When you try to decide between two variables, if left is existing, then use left. If not, use the right one. This is basically trying to do ternary variable checks using type coercion. Type coercion, I mean, because these are binary operators. So these are like A or B, or A and B. These are binary operators designed to use with deciding where to go in your code, basically use them in conditionals. Yeah, that's the word, sorry. But right here, we are abusing these operators and forcing these right and left variables into booleans and try to decide which one is existing and which one is not. But the problem here is that 0 and false are considered falsy values. So if you try to do 0 in here, it will be evaluated as false. But 0 and false are also values. They contain information. Sometimes 0 is a very useful value, like how much the temperature is. It doesn't mean that there's no temperature. It means it's 0, that water is going to become ice. So the 0 and false are meaningful values. And they propose this new operator, the double question mark. And this is ternary testing explicitly for null and undefined. So if left is not null, nullish, or undefined, then it will evaluate as left. Everything else will be evaluated as right. Some examples. This is the problem. False and 1, 2, 3 is basically false. Now, if I'm expecting a value where false is meaningful, this won't work. False and 1, 2, 3, then my value will be 1, 2, 3. Also the problem, the false is coming in and I can't use this. With 0 is the same thing. In null, now that's working because I'm not really interested in null, so this part is okay. It's my variable is null, then give me this number. I can't use this because then null is evaluated and I will get null. So with the new Nullish coalescing operator, if I have false, then this line will evaluate as false. So it's like this. But I can use this both use cases. If this variable is null, like here, then I get the default value I wanted to use. So basically, this is very useful to check for variables if they exist actually, and they really don't contain any information that you want to use. Very good question. We'll get back to that after the talk. The next thing is trusted types. It's coming to stage 0, so it's like really an idea, but this is how Google protects their applications from cross-site scripting. They're using a content security policy header in the HTTP request called trusted types, and there they list their own created types. Now, this proposal will protect so-called DOM things from cross-site scriptings. What are DOM sinks? DOM sinks are anything that is in the DOM except some code or script or something that can be a possible vulnerability, like inner HTML, source or href, anything within a script tag or anything within an on-click or a mouse over property. This is how it works. You set your response header. You set my trusted type is safe HTML. And in your page source, using this new API, you create a policy called safe HTML. The names has to be the same. So you define it in a header, and then you define it in a code. Then you create a new method called yes, there should be a T there, sorry, create HTML. This basically does some sanitizing, so if some input comes in, you're pretty sure that your sanitizer will do the work and the output will be safe. And then you can set element inner HTML, my policy, create HTML, clear this please, and yeah, the code is going there into the HTML and everything is fine. But if you try to assign inner HTML anything else, it will throw an error. So basically, your elements are safe for HTML injection. Well, you can say, yeah, what about when the attacker tries to create an injected script and then create their own trusted type? So the response header is the same. There is the safe HTML and my trusted variable, trusted policies. And the attacker tries to create a new policy, like extra safe HTML with their own fishy HTML sanitizer. And this throws an error because this name is not listed in the headers. So the attacker can't create a new policy, basically keeping your code and your DOM safe. There are some types they propose, like HTML, script, script URL, or URL in general. So you can create your own URL parsing and URL sanitizing code that can be implemented within your browsers. And this is a work that will going to happen with browser implementers, with the v3c as well, because it has to be integrated with the DOM as well, not just the language, not just JavaScript. Moving forward, the dynamic import, this is the very last step for dynamic import. It's in stage 4. This is basically a mechanism for importing code later, or a module later. Also, when you try to import something from something, you're using the new module syntax. Those are static calls, basically. They are synchronous. And you can't create the module name like from a script, like concatenating scripts or creating a module name from a variable. You can't do that. With the dynamic import, you can create the module specifier like you want. So if you have modules from multiple languages, you can create the module name from the language your browser is using actually. It returns a promise, so you can use all the promises that you want and use all the async code you want. It's a pseudo function, basically. It's really good for code splitting. It's already implemented in Chrome, Safari, Firefox. There are experimental Node.js modules. There are Webpack rollup and parcel implementation. Also, it's handled in Babel, TypeScript, and Acorn. So this means basically you can use dynamic import today. Moving, we talked about promises. So there's a new combinator for promise, and it's called promise any. What are combinators for promises? You probably know promise all and promise race. And there are two new ones called all settled and any. Before we try to reiterate what are those, let's do a quick terminology. A promise combinator is a function that takes an array of promises and runs them, executes all of them. Short-circuiting means that the evaluation of these promises stops immediately and returns with a result or an error. This means short-circuiting. Pending. It means it's a promise that is still ongoing, it's still happening. Settled. A promise that is not ongoing, not pending. A settled promise can be fulfilled or rejected. So fulfilled, it has a successful value, and rejected if it has a failure or an error. So the two ones we already knew is promise all. Promise all stops and short circuits when any of the promises is rejected. So any of the promises fails, promise O stops. On the other hand, it waits all the promises to fulfill and then give you the result. Promise race, on the other hand, short circuits when any of the promises is settled, either with an error or a successful value. So we have a number of promises, and any of those basically just stops, then the race is over. And this is the winner. I don't care about the result. It may be an error, maybe a value, but the promise race stopped. The two new ones, the promise any. It short circuits when any of the promises is fulfilled. So basically, it's an opposite of promise all, where any of the promises is rejected, it short circuits. Promise any will stop and give you a value if the first promise is settled and successful. Promise all settled is the opposite of promise race. It does not short circuit after all. It completes when all of the promises are settled, either with an error or a result. So it waits for all the promises to be handled and served or rejected. Moving forward, another topic. This is an interesting one. It's not like per se more technical. There's a new standard called ECMA 402. Basically, it's a internationalized datetime formatting library within the language, within JavaScript, within the browsers, within implementations. And what you can do with that is create localized date and time formatting on the web and in Node. And this proposal is about adding a new quarter options. This is about what the discussions, what they have at TC39. So not just JavaScript languages and features, but like problems, and asking the TC39 committee and the community about what do they think about this. So in this case, they try to create a new format for the quarter, which means if I want to create a quarter year, and it's short format, it's usually called Q2. So if you're working with companies who have some yearly plans for, I don't know, what we'll do during a year, they have used Q1, Q2, Q3, Q4. This is the short quarter naming. You can create a long format, like second quarter of 2019. And the power of this API is that if you set the language to Chinese, then you have the same format in Chinese without using any library. It's basically in the browser, in the runtime. And this discussion was about, okay, we have these quarters, years, part of years, splitting years up like to 4 pieces. But then they started to discuss the problem. Like, okay, how does quarter, the idea functions with situations when the calendar is not divisible by 4? For example, in the Hebrew calendar, sometimes there's a leap year when there are 13 months. How do you create a quarter in there? So this is like a problem. They don't know how to solve it. So they go to people and ask them, what should we do? What do you think? Also, they ask the question, are there any year divisive solutions? Like, how can you divide a year? You can create a half year, you can create a third year. What are any other years, like, for example, seasons? Seasons, you can split up years for seasons, like winter, spring, summer, autumn. It is also a new concern because winter is leaping through years. So how do you solve that? It would be interesting to have an API to, okay, I want the winter of 2009, and it gives me some months that can be used for 2009 winter. Will it give me January, or will it give me November and December? November is autumn, right? Shit, sorry. So some of the discussions are really like theoretical, like this one, and it's really interesting to see the problems they face. Like, how do they do this? And also the division of the 4 quarters, sometimes they're not happening like in seasons, sometimes they're not happening like from January. For example, in England, the financial quarters are starting from like March or May, so like completely buggle thing, but you know, they drive on the other side of the road, so. So like, how do you tackle these problems? So it was really interesting to see that. Let's move on. A very fast topic, top level await. What is the problem? The problem is that if you open a new JavaScript file or JavaScript module, you can't type that await some async function and just be happy about it. No, you can't do that right now. There will be a parser error, and it will tell you that, sorry, using the await keyword can only be used in async functions. Yes, you need an async context for that, and usually people create an async IFE for that, which is something like this, like lots of parentheses, and it's ugly. So they want to solve this problem. Why can't you do this? Why we have to create another context? Why we have to use another resource, like creating new context in the browser, in the runtime, stuff like that. The solution is, the solution is top-level await. So you can use await in module context whenever you like. You don't need wrappers, you don't need IFEs, you don't need async context instantly. You just use await. It sounds too nice to be true, right? Well, yeah, the main concerns are strange. It's coming from modules and module parsing. So how does async work? If you remember your learning curve, async stops the execution of that code at that part until the underlying promise of async settles. The other thing you have to know about is importing modules is a synchronous operation. So when you create import or use require in Node, that is basically happens before your code actually starts to run. So import is a synchronous operation. If a Node module or a module is async, so there is some async thing happening there without creating an async context, importing these modules would stop everything until these async things resolve. So if you have a module, you don't know that is an async module or not. If I import that module, will it stop my code until it fetches all the URLs from the config file until it resolves, and then the importing continues? What will happen? Quoting the creator and writer of this proposal, Miles Borins, asynchronity of an imported module is not visual. You don't know from the outside if that module contains some asynchronous code. And importing these can have potential performance issues. So somehow it should be visible for the developer that that's a problem. And basically, this is the main concern about top-level await, that you cannot just await any code in the interweb and just use them, because you don't know if it will stop the executing your own code and fetching 100,000 Google queries or something like that. Quick recapping, promises are running in microtasks, and this means the execution order of these tasks and promises are not guaranteed when you're trying to use top-level await modules. So await is based on promises. If you have modules full of awaiting code, that it will be a hornet nest of microtasks, and you don't know the execution order of your code anymore. So a possible solution, and it's now in stage 3, so this probably will be implemented in browsers, at least behind the flag, is called import await. Import await works as importing code, and it works for synchronous and asynchronous modules as well, but it delays execution and waits only for the imports on the module, but does not block the code itself. So it blocks the execution of your code until all the modules are resolved, the imports are handled, and after that, it creates a new microtask and starts to execute them as well. So the remaining module body is scheduled in a new microtask. And if a module graph has no top-level await, so if you're using your own code right now without top-level await, it executes synchronously like the old way. It doesn't have anything to do with that right now. It will execute the same way it does now. It also does one thing. It will optimize the async execution. So it will try to execute anything that is synchronous synchronously, and then anything is asynchronous, it will put it in a microtask and execute it a bit later. But basically, it won't slow down your code. Everything will be done in parallel. So this is the current state of top-level await. It will introduce a new import method as well. And basically, this is the solution they can do this. This is the price they have to bring and you have to pay if you want to use top-level await. If you don't want to use top-level await, don't worry. But probably you will use and know this new import part, that importing everything will be a dynamic or an asynchronous thing. And it's still under discussion, it's still a heavy topic, and in Webpack it's under experimental flag, and there is major implementer interest. So it's not, they are not implementing it yet, but Chrome, Firefox, and Safari probably will ask a lot of questions about this. What if, what if, what if, what if? And discussions are ongoing, like cycles, deadlocking code, modules killing each other during runtime. Also, if they check if there is a conditional asyncness, so like checking the code and checking the modules, if it's not async, if it's async, what should we do? We should pre-optimize that. It's not an easy topic, and but hopefully it will be a very exciting thing because, yeah, I don't have any code examples, but basically, if you ever used IFEs, async IFEs, then you can imagine forgetting those and just write your code, asynchronously create a new database connection, just then use that database connection in your code or using anything like that in browser code. It will be very, very comfortable, at least. Okay, let's talk about TC39 and you. The community wants your feedback, so go to GitHub and check them out. This is how a meeting actually looks like. These are people, so there's nothing serious thing going on. Sitting in a room, relatively boring, having discussions, having coffee breaks, lunch breaks, and working, basically. It's nothing really, I don't know, that doesn't look exciting. The discussions are exciting if you're interested in that. There are some nice things like the ECMA Secretary General, so basically the main chief people of ECMA, is called István, and he's a really nice old guy. And I asked him that, your name sounds Hungarian, you know. And he responded in Hungarian, yeah, it actually is. And we started to talk in Hungarian, and he really enjoyed that he can use the language again, and he asked me about Budapest. And the last time he was in Budapest, the Erzsébet tér, where the Gödör and Aquarium Club is, it was a bus station. So it was like tens and decades ago, basically. And we had some very good... Sorry? Don't spoil my thing, please. It's spoilers. So, yeah, we were talking about that as well. I wouldn't say anything too quickly about that. We'll see. We really hope to do that. So this is basically discussions between people on behalf of implementers, on behalf of coders, on behalf of browser vendors. Sometimes there is fun. So these guys are here are from Apple, and they were proposing a new standard library. And after their presentation, they just put this one slide in, that one more thing, and everybody was like, oh God. So sometimes it's funny. And this very discussion was very interesting. So they were talking about built-in modules, if you can read that. The original title was JavaScript Standard Library. They want to create a set of libraries that you can use right now from NPM, and they want to put that into the browser. And this is the idea. They create namespaces like web, node, IoT, date, time, strings, stuff like that. And you can import those modules right from the browser without using any NPM. You can polyfill those from NPM if you want to, but if you don't want to use those, you can use the browser implementation for those code. And the discussion was like, okay, how to decide what to put in the browser, what libraries. So if there is a good international or good date library like Moment, should we just pick Moment and put it in the browser, or what? Or there's another one that is emerging and more interesting and more performant. Should we use that? And how we create these namespaces, how we govern this whole thing, that what goes in and what stays out. And the whole discussion was like this. And after this talk, some people from Google and Netflix and I think Bloomberg, yeah, they stood up and created almost the same proposal, but they called it, the JavaScript standards. JavaScript Commons, sorry, JavaScript Commons. It was almost the same proposal, like use modules from user land and implement them, somehow bring them into the browser, into the runtime. And after these discussions, they were basically hacking each other's neck. That why didn't you communicate with us? This is the idea that we should do this way. No, we should do that way. No, we should. And they were basically shouting at each other. And after all, the time box was adjourned, and everybody was going out there smoking separate little groups and really, really frustrated. And I asked some of those, okay, how do you plan to do this? Like, if there is a module called unique identifier, UUID, if you use Node and you create a unique identifier, you can use this module called UUID, and it's a very popular library. So for say, they want to bring that into the runtime or into Node. What do they do? Do they go to the library maintainer and say, hey, your library is nice? What would you say if you put it in the browser? And how do you update that? How do you create, security patches on that? And it's just mind-boggling. And they said, no. What they do is take a library that is JavaScript Commons, like really, really used, heavily used, like LeftPad, and pick the API from that. And they put the API into the implementation and let the browser implementers to implement the background. So this way, the competitive thing between browsers can stay. So if there is a unique identifier generating library or an API implemented in browsers, and sometimes the implementation from Chrome will be faster and more performant, like from Firefox, then Firefox team catches up and their implementation will be faster and more performant. The API stays the same. You can import that code wherever you want, wherever like browser or node you are. You can import the code and use it, but sometimes it will be faster in Chrome and sometimes it will be faster in Firefox, but that simply happens with JavaScript right now every day, so with every new browser release. So it won't change a thing. They just define the APIs and bring these APIs into the JavaScript Commons. And if you want to polyfill that because you feel your own implementation will be faster and better, you can do that as well. So it's a very interesting topic, and it was the first time I saw, the first day was like, yeah, it's going to stage two, everybody's happy, everybody is happy, and everybody was like, what is going on? It's never been so peaceful. And was like, there are more arguments like this, and then I saw they basically hacking each other's neck, and then they have to put down their ego on the table and sentence like this, and I was like, whoa. So it was really good. There's a proposal survey, and I really suggest you to take a picture of this URL and visit this site. It's a coding survey on your opinion, testing and using new proposals. So when you go to this URL, it won't test your coding skills, no. It will test that how do you feel, how do you like a proposal when you try it out. There will be some coding part when you can refactor code using a new proposal. And then you have to give some feedback. Do you like it? Did you like it? What do you think about that? Do you think it's readable? Do you think it's usable? Do you like it at all? And more of these surveys will come probably because it's a really good initiative to ask the community, like directly ask coders, what do they think about new proposals? So try this out. It's really fun and helpful. There's a new website for TC39. There was a beta website on the GitHub pages, and Hungary was the 4th country with the most visits. And I was like, wow, it's really good. And they moved it out from beta, and then now it's TC39.es. they came up with this URL, yeah. Like ES is like ECMAScript, so it's like funny, I don't know. This is ECMAScript, TC39 humor. And get involved. Go to github.com/tc39 and check out the proposals, give feedback, read them, learn what's coming up. You can see it's, the proposals are ordered by stage, so you can see what's coming really near to your browser, really near to your code. Or there are the early stages are like, okay, this is interesting, I really hope that this will get traction. Also, if you have a question about TC39, the process, like you have a question like, should this be a proposal? I have this crazy idea. What do you think about this? Should it be a proposal? Then go to this URL. It's a discourse group, and you can discuss things like things like these over there. So don't create a proposal if you're not sure. Just go there and ask them that, hey, do you think it's a good idea? And they, hey, yes, create a proposal right now. Here's the knowledge base how to do a proposal and do it. And maybe you will be a champion for a new ECMAScript feature. And yeah, that's it. Thank you. I hope you enjoyed it.